Hi everyone, so now we are going to talk about how you can do fast exponentiation using bit masking. So you might not have heard about this term, but this is an important concept that we use as a sub problem in many other problems. Okay, so what is exponentiation? It's basically computing a raised to the power n, where a is a number and n is also a number. Let's say 5 raised to the power 3, this is 125. Okay, or let's say 3 raised to the power 5, this is 3 multiplied by 5 times. Okay, so 3 into 3 is 9, into 3 is 27, into 3 is 81, 81 into 3 is 243. Okay, so this is what fast exponentiation means. And if you simply do this multiplication n number of times, it will easily take order of n time, but we are going to do it in a better manner. We are going to do it in a log of n time, and I will teach you how you can do it. Okay, so let's say we have some number a, let's say 3, and we have n, let's say 5, and we want to compute a raised to the power n. So what I will tell you is, you try to visualize this operation like this. This is 3 raised to the power 5, and what you do, you convert this 5 into its binary representation. Let's say 3 raised to the power 101. Okay, so this is just for understanding purpose, and later we will see how to write it in the form of a code. So what this basically tells us, if we talk about how many bits a number is going to have, so any number n will have at most log of n bits. If you talk about, let's say, number 15, so 15 has 4 bits, that is log of 16. Okay, 15 plus 1, that is, so 1 more than log of n, let's say, in the worst case. And let's talk about a number 8. Okay, so 8 also has 1,000,000, so that is again log of n plus 1. That is at most number of bits that it is going to have. So log of 8 is 3 plus 1, that is 4. It is going to have at most 4 bits. What is 15? Log of 15 is roughly close to 4. 4 plus 1 is 5, or it is 3. 3 plus 1 is 4. So at most 4 bits it is going to have. So for any number n, we are going to have at most log n number of set bits. Okay, although every number is a 32-bit number, but I'm saying the last set bit would be at the position log n or log n plus 1. Okay, that's a property that we should know. So what we need to do is, if we are writing a raised to the power n, let's say a is 3, n is 5, so we will write, okay, 3 is 101, and what we are going to do, we are going to iterate over these positions. Okay, we are going to iterate over the bits of n, and every time what we can do, we can generate some powers. Okay, so at this point this is nothing but, we can write it as the number itself a. At this point we can write it as a square, and at this point we are going to write it as a4. So what we are going, as we are going from left to right, we are going to do a work. We are going to start from a raised to the power 1, and every time we are going to the next bit, we are going to square the previous power. Okay, so now what you can observe is, if you are able to generate these powers, and then by multiplying a subset of these powers, you can actually get 3 raised to the power 5. How? So if you look carefully, that this set bit is 1, so if you pick this power, and if you discard this power, and if you pick this power, and if you multiply these two, what you are going to get, you are going to get a raised to the power 4 multiplied by a raised to the power 1, which is a raised to the power 5, and a is what? A is 3 raised to the power 5. So this is going to give you the result 81 multiplied by 3, that is 243. Okay, so basically by just iterating over the bits of that number, we get to know what powers we need to multiply. Now you may ask how we will implement it. It's very easy. So initially we will take our answer to be 1. Okay, that is 3 raised to the power 0. Then we will find out what is the last bit of 5, so it is 1, and what is the current power we have, that is a. So we will multiply our answer with a. We will discard this bit, we will move on to the next position, and we will square our value. Okay, so let's say power of a, so this was initially 1, this was a, then after the next step, this power became a square, and the bit what is the next bit? So initially the bit was 1, the next bit is 0. So if it is 0, we are not going to do any work here. Okay, so we go to the next position. The power of a is now a4 because we squared the previous value, and the bit is now 1. We are talking about this bit. So if it is 1, we are going to multiply this a4 in our answer, and our answer is going to become a5. And now if you extract the next bit, it is going to become 0. And we have already covered all the set bits of 5. Okay, and we are done. So finally what you're going to have, you're going to have your answer that is equal to a5. Okay, and since this number n had log n bits, we could just find out this in order of log of n time. So I hope this concept is clear, and now we can quickly jump into the code as well. So I'm going to write a method. Let's say int fast exponentiation, then I get the number a, I get the number n. I can say, okay, let us assume our answer is 1, and while this number n is greater than 0, we are going to find out the last bit. Last bit is nothing but n and 1, and if the last bit is set, then we are going to do some work. Otherwise we are just going to compute the next power of a. So the next power of a would be a into a, that is the previous power into itself, square the previous result, and then n would be updated as n equal to n right shift 1. So every time we are discarding one bit from the right, so we are doing n equal to n right shift 1, and initially a is equal to a, so this is a, then it becomes a into a square, and it becomes a square into a square, that is a4. So this is actually multiplying the previous powers. So if the last bit is set, then what we need to do, we need to multiply our answer with whatever answer we have multiplied with the current power of a. Okay, so that may be a, that may be a4, whatever it may be, but we know that this a contains the right power. So from here what we can do, we can return our answer, and we are done. We can say int a comma n, scene a comma n, and we can see out fast exponentiation a and n and l. And now if I show it to you how it is going to work, I can say maybe a is 3, n is 5, I get the right answer. A is 2, n is 10, I get the right answer. A is 5, b is 3, n is 3, I get the right answer. So I hope this is now clear. This is what we are exactly doing. We are updating our answer when the last bit is 1, and we also have the right power of a generated because of this repeated squaring of the values. Okay, so that's it for this lecture. Thank you.